Hello, my name is David Alberto, and I'm going to talk about the Pia of Chemistry. The teammates are Daniela Salazar, Natalia Mendoza, Paloma Dimas, Emilio Sea, and David Ayala. And we're from the group 307, and we are the team number 4. And our topic is going to be about acids and bases, part 1. One classification of inorganic compounds are acids and bases, formerly called alkalis. And in the Irish writer and amateur chemist Robert Boyle assigned the set of properties to each group according to taste, texture, corrosivity, among other features. Then Humphrey argued that acids contain hydrogen and not oxygen. But then, as more acids were identified, it became evident that the common element to all of them was hydrogen. The bases were considered as compounds that neutralized the acids, producing salts as a result of neutralization. But at this time, it was not possible to verify any theory that linked the alkaline properties with a specific element or chemical grouping.
3.1 Acidic and basic solutions. Acids and bases are chemical compounds that have specific characteristics that make them indispensable in multiple chemical processes that take place both in living organisms and in industry. Acids are present in various natural products such as citrus fruits, like lemons, grapefruits, or strawberries. The hydrochloric acid in the stomach is part of the gastric juice that is responsible for degrading food in the process of digestion. On the other hand, bases contribute to various vital processes in the organism, such as the coagulation of blood and the control of excess amino acids, among others. Acids and bases are always in solution, that is, forming homogeneous mixtures with water as a solvent. They neutralize each other, forming salts as a product of the reaction between them.
Properties of acids and bases. Acids. Aqueous solutions of acids are electrolytes, meaning that they conduct electrical current. Some acids are strong electrolytes because they ionize completely in water, yielding a great many ions. Other acids are weak electrolytes that exist primarily in a non-ionized form when dissolved in water. Number 2. Acids have a sour taste. Lemons, vinegar, and sour candies all contain acids. Number 3. Acids change the color of certain acid bases indicates. Two common indicators are litmus and phenolphthalein. Blue litmus turns red in the presence of an acid, while phenolphthalein turns colorless. Number 4. Acids react with active metals to yield hydrogen gas. Recall that an activity series is a list of metals in descending order of reactivity. Bases have properties that mostly contrast with those of acids. Number 1. Aqueous solutions of bases are also electrolytes. Bases can be either strong or weak, just as acids can. Number 2. Bases often have a bitter taste and are found in foods less frequently than acids. Many bases, like soaps, are slippery to the touch. Number 3. Bases also change the color of indicators. Litmus turns blue in the presence of a base, while phenolphthalein turns pink. Number 4. Bases do not react with metals in the way that acids do. Number 5. Bases react with acids to produce a salt and water. Bases are less common as foods, but they are nonetheless present in many household products. Many cleaners contain ammonia, a base. Sodium hydroxide is found in drain cleaner. Antacids, which combats excess stomach acid, are comprised of bases.
Acid-basis theories. Theories about the behavior of acids and bases have been developing for just over 100 years. In 1884, the Swedish scientist Svante Arrhenius proposed the first definitions about these substances. Acids are substances that have hydrogen ions in their structure and release them in contact with water. Bases are substances that have hydroxyl ions in their structure and release them in contact with water. One of Danish origin called J. N. Bronsted expanded the concepts of acid and base by defining them as a function of the hydrogen ion, which they called proton. Bronsted-Lowry defined the acid as a proton donor substance, and a base as a proton acceptor substance. The American chemists Gilbert and Lewis proposed in 1938 the last acid-base theory, in which he explains the acids and bases depending on the pairs of electrons that are shared in the formation of a coordinate covalent chemical bonding. He defined an acid as a substance capable of accepting a pair of electrons and sharing it in the chemical bond, and a base as a substance capable of donating a pair of electrons and sharing it in a chemical bond. Some examples of common acids and bases are hydrochloric acid, sulfuric acid, and phosphoric acid. And some examples of bases are potassium hydroxide, magnesium hydroxide, and aluminum hydroxide.
3.4 Ionization of acids and bases. The process by which solids release ions in the presence of water is called ionization. A strong acid is an acid which ionizes completely in a solution of water. A weak acid is an acid that partially dissociated into its ions in an aqueous solution or water. A strong base is a base that is completely dissociated in water in aqueous solutions. A weak base is a chemical base that does not ionize fully in an aqueous solution. Ionization of acids. The degree of ionization refers to the strength of an acid or a base. A strong acid is said to completely ionize in water, whereas a weak acid is said to only ionize partially. As there are different degrees of ionization of acids, there are also different levels of weakness for which there is a simple quantitative way to express. Ionization of bases. Some bases like lithium hydroxide or sodium hydroxide get completely dissociated into their ions in an aqueous medium solution, which is referred to as a strong base. Therefore, the ionization of these bases yields hydrochloric ions as OH.
Well, in this postcard, we have seen the different characteristics that share acids and bases, and also the different theories depending on the donator of electrons or protons, obviously depending on which one. It can be Bronsted-Lowry or Lewis. And also it is important to know the acids and bases because it is an essential topic about chemistry to know how the compounds work together.